Hi guys! Hi, I am Nickey.
Hi, I am Jackey.
Together we discuss future of design.
And also, Jackie, talking about all these tokenizations, I have generally seen when a model is introduced in the market, it is released with certain parameter. For example, 20 billion parameter model. So, what exactly do you mean by that?
This question even I had when I first got into this LLM world. I've been hearing like 20 billion parameter model, 70 billion, 400 billion. Recently, I've heard Grok could be the first model that could have 1 trillion parameters. But essentially, a parameter is it's just a number that model learned during the training. Think about like brain, and let's say you have different knobs in your brain. So each knob is one parameter. If a model says that it's 20 billion parameter, which means it says 20 billion knobs that you can use to tune it. More knobs means you have more flexibility in tuning. Less knobs,
Right.
you have less flexibility of tuning it. So one thing we've been hearing a lot from everyone that 20 billion parameter is less smarter than 70 billion parameters. It's right to a one point because it's 70 billion parameters, so it has more tuning, which means it can reason more. And yes, it's more smarter, right? But the question as a design engineer we should ask is, what is our use case? For example, our use case is about high school students write some poetry. Why do you need like 70 billion parameter model? You don't have to reason so much. You can just go with a smaller model that can restructure the initial draft of the high school students into different format.
Saying is that the selection size of the model depends wholly on your use case. Let's say if I have a simpler use case, so I will not go for such massive parameters model, right?
Exactly. So smarter models, right, will be very heavy, will be slow, and it will be harder to control. So in a nutshell, parameter decide what to pay attention to. It
All right.
also decides what to ignore and
Yeah.
how strong is the connection between the ideas. So this is what the parameter does.
So what do you mean by the strong connection between different ideas?
Ideas are nothing but what it has learned. Let's take an example: doctor, hospital, and let's take banana. Now these are three words. What I mean by relationship is the LLM knows, the parameters can understand that doctor and hospital are having a very strong connection, whereas doctor and banana has less connection between them. And same way, hospital and banana has less. When the user puts up a query related to doctor, it knows that the doctor is strongly related to hospital than a banana. So it'll never bring banana in its response. This is how the AI knows what usually goes together. So now, what a parameter is. Now let's say you have one parameter, which means one knob. If you want to tune your model, and you must have found out that doctor and hospital is not that strongly related, so you can use parameter to increase the relationship between this and can decrease the relationship between these two, which means in your responses, whatever you give, it will always relate doctor with hospital. So this is what you will do with the parameter. Now, as a design engineer, we don't have to go that deep because it's not so easy that you will go and end up tuning each parameter, because there are like billions of parameter, and more big is the model, like 70 billion parameters. If you increase some relationship somewhere else, will start impacting. It's like a trade-off. The reason we are talking about this is it helps us in understanding how to define our prompts, which we will discuss in the later part of the series. But these are the basics. Once we know what's a parameter, what's a token, we know how actually this AI works. Sometimes we have seen like we just write some kind of prompt and it just spits out any kind of information which is not useful. So it's not a problem of an AI, sometimes it's a problem how we write it, because it looks at each information. Sometimes structure is bad, which means it perceive a different information and gave a different sort of answer.
So from this, you mean that it is very essential for anyone to write a proper user query.
Right, and you will see in more deep how it will, so when we'll have the transformers and stuff, then you will understand why structure of prompt is so important. Or if you want a good answer, the clarity of your thought, what you have in your mind, and how you articulate in the text, it's so important for AI to understand what exactly are you trying to know, and it can respond accordingly. Sometimes we see people write the prompt, but they write some parts in the top, it's not structured. So just think about it. If you want to talk to an intern, and if you just give your thoughts in like non-structured format, he will end up doing something else. But if you give the same information but well more structured, it knows how to process that and give you far better outputs. It's same with the AI. We have seen parameters, why it is so important. Although we know that more parameters, it's more smarter, but not necessarily it will always help you in your product use case. A small parameter can be equally good, and we will see how to select a model.
I've generally seen whatever prompt that I give to the LLM, it doesn't give me a proper answer. So the
Yes.
efficiency of output also is dependent on the input that the user is giving. It is not just if you select a prominent model, let's say of 120 billion model, but the output is also dependent on your user query, which means your input.
No, you're 100% right. Want to give you one more analogy. So I have my friend who always raves about GPT-5. He says, it gives me better responses. It does give you. And then I have my other friend who still gets such an efficient response in 4.0 model itself. Now, we know like 4.0 model is smaller than GPT-5. Now what happened here? He is getting response better in 5 but not in 4, the first friend. I would say it might be a problem of his prompt engineering, because my same other friend got a good response almost similar to what he has got in GPT-5 using 4.0, which means he could better make the AI understand his intent. Just think, my friend 2, if he gets hold of GPT-5, he will be getting at least 10x more efficient response than my friend who is using GPT, because he is just banking on the model power. But nobody's talking about the cost. Today, GPT is free, but if you go and start using API keys from GPT, you know that GPT per million token is like, I don't know, but it's next more than 4.0 costing. For example, if GPT-5 cost you $21 per million tokens, then 4.0 will just cost you around probably $2 per million tokens. So it's how efficient you use. Now for coding kind of cases, yes, GPT-5 makes sense. But if it is a simple product itself, if my friend 1 is the designer, he will end up costing huge to the business. And in that case, my business should be hiring friend 2.
Yeah, exactly. I think as a design engineer, it is essential for us to write a proper prompt. We should know how to do prompt engineering well. For that, we will actually put a video here to make everyone understand how prompt engineering actually works and what are the better ways to write a prompt.
Yes, if you want to learn more about it, just comment it and we'll just create a episode for that.
Apart from the parameters, I've generally seen weights and biases also written among the models that have been launched. What are they exactly?
Weights are how important something is. It measures importance. And bias is the default preferences. For example, as a designer, how it impacts us. So we are generating a UI. Let's say this has 2 components. So one is color and other is layout. When it comes to weight, it helps in defining which one is more important for you. So if you increase the weight of parameter, you are influencing the importance of that relationship. It will be how much you care about color versus layout. And a bias will be your predefined style or a preferences which is already set while training the model. So what happens is while training the model, they must have trained on some data which created a bias.
So by weights, you actually mean the knobs that you were talking about, right?
You're 100% right. So mostly people say parameters, but parameters means weights plus biases. So you basically tune this. So now the question is how it helps a design engineer to know about weights and biases. If you ask me, in reality, we are not the people who will be going and tuning these weights and biases for parameters. No, our job comes when, let's say, a business has already selected model 1. For per their use case. And now this model is in production, which means users are actually interacting with the LLM. We logs of our outputs. So we set some evals to identify and measure what is our output to the user. Now what we can do is we can find out what are the default been baked in. Is it responding differently to different races? Is it responding differently to specially abled people, being rude to people who have rude prompts? So we identified that. And second, we also identify which things it's prioritizing more. So let's say the user said, hey, generate me a beautiful UI. Now what AI is doing, and let's say it's a UI generating application. So by the mean of beautiful, so it is taking beautiful as color, which means it's generating some UI which has multicolor, or it must be prioritizing some concepts that's based on Apple design, whereas it should have prioritized more on the layouts. So what you do is you identify that your LLM is prioritizing colors over a layout. This kind of information you gather, you know how the model is prioritizing the importance of certain things. Now, if you have AI researcher in your company, you can go and pass this information to them. They can go and tune the model. They can tune the parameters. But if you don't have it at your disposal, then what you can do is you can start creating these policies. Like for example, the guardrails. You can define some system prompts. This is what we have been talking in our previous video about designing policy constraint, evals, guardrails. So this will help in making sure that AI is responding better to the user query. So this is why we should know about weights and biases, so that we identify them, and that will help us in defining the behavior of the agent much more better and according to the business policies.